Stanford University.
So welcome to Stanford CS 193P. This is Developing iOS Applications, winter of 2017. So today I'm going to give another brief set of slides on Model View Controller, this design methodology that we're going to use to build all of our iOS apps. And then I'm going to continue the demo that we started on Monday. We're going to actually incorporate MVC into the calculator. And it's also going to be an opportunity for me to show you a lot of other cool Swift language features. So what is MVC, Model View Controller? What is that? Basically, it starts out being a way that we divide up all of the code in our app into three different camps. Okay? These three different camps are the model camp. The model is the what of your app, so what your app is. So in the calculator case, it's the brains of the calculator. It's a thing that calculates. That's the model. And that's in UI independent part. It's what the app is, not how it displays or anything like that. How it displays is the controller's job. Okay, so the controller decides how to take this UI independent thing, the model, and display it on your screen and interact with the user. That's what the controller job does. It's the how it displays. Okay, model is the what it is, controller is how it displays. The view is the minions of the controller. Okay, things that the controller uses to do its job. Almost always, these things in the view are generic. Things like UI button or UI scroll view. Okay? Things that come from Apple or somewhere else, even things you write, and you generally try to write them to be pretty generic, reusable UI things. Okay? And the controller is trying to use those generic things to build a specific UI. Okay? Now, the key to making MVC work is managing the communication between these camps, because if we don't manage that communication, we might as well just put them all in a big camp and they can all talk to each other however they want. Okay? So if we're going to have three camps, we've got to think about how they communicate. So I've used this road sign kind of imagery here. Okay? The roads, like the road lines in the middle of a road, between them to help you visualize what is allowed in terms of communication. So let's talk about every boundary here between all of these camps. Let's start with the controller talking to the model. Okay, can the controller talk to the model? Absolutely. It can say anything to the model that the model publicly allows to be said to itself. Okay, so it's a green arrow, it's a dashed white line on the road. You can go across there all you want, and you can see why this is. It is the controller's job to get that model onto screen. It has to be able to talk to it all at once. So there's no restriction of the controller talking to the model. And similarly, there's no restriction of the controller talking to the view, because the view are the controller's minions. Right? So you got to be able to tell your minions what to do without restriction. Now, these connections between a controller and a view, we call them outlets. And you've already seen one in the calculator. We created an outlet, if you remember. It was called display. Right? It was an instance variable in our controller. Remember that class view controller we saw on Monday? That's the controller of the MVC that we built on Monday. And that display var was an outlet, and it's just wired up to a UI label in our view. The UI label is one of the minions for the controller in the view. Okay, so you've already seen that happen. The model and the view can never speak to each other. Okay, double orange line there, no crossing either way across here. And this makes perfect sense because the model is completely UI independent. And the view is completely UI. That's all the view is. So they have nothing to talk about, these two guys, okay? Because they're completely, different camps that make no sense to talk to each other. It's up to the controller to manage communication between these two. So never shall you just communicate between those two camps, all right? How about the view talking back to its controller? Can the view, those minions, can they talk to its controller? Now, this is something you would clearly want because the minion's got to work with the controller, but it's a bit of a problem here because these things in the view are generic. They're things like UI button. The class UI button shipped from Apple last year. It knows nothing about a calculator. So how can that UI button talk to a calculator? Well, we can do it. We just have to sort of do it in a blind, meaning we don't know the class of the thing we're talking to, and structured manner so that we can clearly understand what communication is happening. So you've already seen a blind structured communication between the view and the controller. It's target action. Okay? So the controller can drop a target on itself by basically creating a method with that @IB action. Remember that from Monday? And then you just control drag, and that lets the view, a UI button, basically connect up to that target. And now every time that the UI button wants to talk to the controller, it's just sending that target action. So that is super simple, blind, structured communication from the view back to the controller. Okay? But that's a little too simple for all the communication that these minions might want to do. Okay? For example, sometimes something in the view wants to synchronize itself with the controller, or it wants to know what the controller intends as it's being used. Let's use the example of a scroll view. Okay? A scroll view, when it's scrolling around, might want to ask the controller, should I allow the user to scroll over here? Or it might just want to tell the controller, hey, the user scrolled down here. Okay? These kind of notifications and questions about whether it can do things, they kind of end up in things that start with these words I have up here, will, should, and did, like should I scroll to here? I will scroll right here if the scroll view is about to scroll, and then I did scroll down here after the scroll view is done. Okay, so those kinds of communications. And the way we make that communication work, we can't just do this simple one method control drag. Instead, we use what's called a delegate. And I'm going to talk a lot more about a delegate in future lectures. But basically the idea of a delegate is it's a var in the view, so like a var on scroll view, and it's of a special type. Okay? That type is called a protocol. I know that a lot of you, even though you have object-oriented experience, maybe you don't have experience with protocols, but essentially a protocol is a way of saying that this type, this thing that I'm talking about, it responds to a certain set of methods. I don't know what class it is. I don't know if it's a view controller. I don't know what it is. But I know it's going to respond to these methods like will scroll, did scroll, should scroll, those kinds of methods. That's all I know about it. So the controller, it signs up to listen to those methods, and then it sets itself as the delegate in the view. Okay, and we're going to see this in action, so don't worry about too much now. But that's how we can have structured communication, where they're agreeing, the view, this generic object is agreeing to send certain messages to the controller. And that way the controller can be of any type and still serve this purpose of controlling its view. Now there's a special kind of communication between the view and the controller that arises because a view cannot own the data it displays. Okay, and what does that mean? That means you don't want to have inside your view class, and remember view classes are like scroll views, buttons, things like that. You don't want to have data in there that is the data you're displaying. I'll give you an example. Let's say your entire iPod music library, let's say you have hundreds of thousands of songs in there. Okay? So I want to have a list of them on screen. So I'm going to use a generic item in my view called table view. Table view, it just shows a big long list of something. It can be a list 1,000,000 items long. Okay? So if I really had to take my entire iPod library and put it in the value of a var of the table view to display it, that would be ridiculous. Okay? Not just from a performance standpoint, but now I have 2 copies of my iPad or my iPod music library, one inside this table view and one in some database somewhere on my phone. That's bad. They could get out of sync, managing the synchrony. What if I have multiple apps doing that? Ugh, it's a mess. So the view never wants to own that data. Okay? So how the heck is it going to get the data then? I've got 100,000 songs. I need to show it in this table. How's it going to do it? Well, it's going to use another one of these protocol-based vars, okay, called the data source. And the data source has different methods in it. It's not will, should, did. It's how many items are in this piece of data. Give me the data at this location. Okay? And that, again, is a var that controller sets in the table view, let's say, that points back to it. And so now every time the table view wants data, it asks the controller. And the controller almost always turns around and asks the model. Okay, give me that data. Now this also allows something like table view that's showing 100,000 items. It can only show 10 on a screen at a time. So it only asks for 10 and shows them. And if you scroll down to somewhere else, it's going to ask for that 10. Okay, and it's only keeping the ones it's displaying. So it's transferring a lot less data, only the data you're actually viewing, 10 out of 100,000 songs. Okay, and so it's a lot more efficient, both in terms of memory usage and everything. Now you might be a little scared, like, oh, every single time I'm going to scroll, I'm going to be asking for this data. But keep in mind, the model for the iPod's music library is this probably a SQL database or something that can serve up data super fast. That's its job as a model, to be the source of that data. Okay, so there's really that is usually not your performance bottleneck. We're going to talk about performance later in this class, by the way. Usually the performance bottleneck is drawing on the screen. Things like getting data out of databases, forget it. Drawing on the screen is much slower, and then going over the network is even slower. So those things tend to dominate the performance of your app, okay? So don't worry about that. So anyway, so that's how, a couple examples how we have this structured communication from generic objects back to our controller, okay? Now, what about, one statement that's good to put in your mind that has all three camps in it is that the controller interprets and formats the model for its views. Because its views are generic, they don't really know how to deal with any particular model. A controller knows about both, so that's part of its job. So a lot of times I'll be saying, oh, the controller's job is to do this. And you'll be like, oh yeah, I remember him saying that, okay? All right, now what about the model communicating with the controller? Okay, now this can never happen as well. Because the model is UI independent, it knows nothing about any particular UI, so there's no way it could talk to a UI guy like the controller, okay? So what happens, though, if the model changes, the data changes? That controller needs to know because he wants to update the screen in that case. Well, the way we do that is with a model that kind of looks like a radio station. Okay? The model basically has a radio station, and it broadcasts on that radio station, hey, I changed, or this about me changed. And then the controller tunes in to that radio station, and when it hears a broadcast, it asks the model what changed down that green arrow there. You see? Okay, so that's the model we're going to use. That's the mechanism we're going to use to get stuff for our model that changes to notify our controller. Some people ask, can a view tune into a radio station? And the answer is, yeah, it probably could. It wouldn't necessarily violate MVC, but the problem is a generic view wouldn't know what radio station to tune into anyway, so it's really a non-issue there. All right, so an MVC like this, though, really is not, like your whole app isn't one big MVC. Each MVC controls either one screen on an iPhone or maybe even a sub-part of a screen on an iPhone or on an iPad. Maybe there's 2 or 3 MVCs controlling what's going on the screen. So how do we build a big app? An app, let's say I'm building an Instagram app. I got to have MVCs for posting. I got to have MVCs for image editing so I can do my sepia tone. I got to have MVC for scrolling through the latest posts that are coming up. I mean, I need all kinds of MVCs. How do we combine them together? Well, looks like this. MVCs, when other MVCs point to them, it's always as part of another MVC's view. So look at the 3 MVCs that are down here in the lower right corner. You see these 3 MVCs? See this MVC up here, this purple one? Look how it points to them as if they were part of its view. You see that? There's no other arrows that point from one controller to another MVC except for that goes through this view side of the MVC. Now, let me help you make that more concrete why that is. Let's say I had an app and it was a calendar app, and it was showing me the year, okay, a whole year's worth of my calendar entries. Well, on a tiny screen, it's barely going to be able to show me the 12 months, let alone the days and the things, right? So it's got this picture of the months. So that's a year MVC, let's say, in my calendar app. So I click on one of the months because I want some more detail. And now that year MVC moves out of the way and puts up an MVC that's showing all the days of a month. Okay, well that month MVC, which is a totally separate MVC, do you see how it's part of the year MVC's view? Because the year MVC is showing months, you want to look at it, it's trying to zoom in on it, it does it with another MVC. And same thing in the month, if I click on a day, the month MVC is going to move out of the way, put a day MVC that shows me all my appointments for a day, and that day MVC would be part of the view of the month MVC. Okay? Make sense? So that's why that's the only relationship we have between MVCs is across this view boundary. Now, there can be other communication, however. Look right here, this MVC, the purple one in the top middle there, it's communicating to a model that's the same model as some other MVC. So MVCs can share the same model. That's perfectly fine. The models are completely UI independent. They don't care how many MVCs are looking at them, okay? Because they don't even know about controllers, right? They're completely independent of that. Also, notice these 2 models down at the bottom, they're talking to each other. That's okay too, because a model can be defined any way it wants. It's UI independent, it can talk to other models, whatever. Now, of course, it's still going to want a radio broadcast if maybe this model changes something in it, okay? But it still can talk directly to the model. So that's the other communication that can happen. But no other communication can happen. We do not want our apps to look like this. Okay, we've got these MVCs, and look, see this view over here is talking to a different controller. This controller is talking directly to another one, not as a view, but just off to this side. You don't want this mess. Okay, if you do this mess, you're not even doing MVC, because everybody's in the same camp. They're all just talking to each other. Okay, so this is no go. And of course, I'll be showing you, not next week, but the week after, how we build these connections between MVCs. For the first 2 weeks, we're just going to focus on building one MVC. Our calculator is one MVC, but we're going to add another MVC to our calculator in week 3, and you're going to see, oh, that's how we wire these things up. Okay, so that's MVCs. Okay, we're going to dive back into continuing our calculator demo here. Again, this is a slide you're going to look at later and say, oh, did I learn all these things? I hope so. And I'm not going to get back to the slides, so let me talk about what's coming up. On Friday, we have this debugging Friday section. I still don't have a room for it, but it will be announced on Piazza. It's going to be around noon, maybe 1 o'clock, maybe 11. I know some of you have conflicting things in that time and might not be able to make it. It's optional. I hope you're all able to make it, however. We'll also, in that one, be going over some like Xcode shortcuts, how to get around in Xcode a little more easily, because I always end up clicking on everything so you can see what I'm doing. But there's command keys you can do to really master Xcode. And then don't forget Monday's a holiday, so don't show up here. And then next Wednesday, the reading assignment I assigned on Monday, plus the programming assignment that I just put on Piazza today, are both due next Wednesday. And then next Wednesday, you'll get another reading assignment and another programming assignment, which we'll do a week later. Okay? Okay, here we go, back to our calculator. Here's exactly where we left off right here. And as I said when we were there, this is a great little calculator. It's nice, but it's kind of bad that this code right here, which is the what of this calculator, what is this? It's a calculator. Here's the calculations happening. That really needs to be in a different camp. It can't be in the controller like this. Okay? So that's the main thing we're going to do in this demo right here, is we're going to create a model for this calculator where we're going to put all this calculation. And then we're going to make this model really powerful and extensible, as you'll see. So we need to create a new data structure for our model, and we do that with file, new file. Anytime we want to create a new class or new struct or any kind of new data structure, this is what we do. So we hit this. It's going to be a Swift file right here. We'll look at it, maybe one or two of these other, actually we probably won't even look at those. It's almost always going to be a Swift file that you create here. Here it is. It wants to know the name. So this is the brain of my calculator, right? The guts of it. So I'm going to call this calculator brain. That's going to be the name of the data structure that I'm going to use here. And I'm going to make sure I put it in the same group down here as all the rest of my classes, like view controller. See that view controller.swift. I'm going to put it in the same place there. All right. So here it is on the left and right. Actually, let's make it fill the whole screen. If we look in the navigator, now we have 3 files. Okay, there's our controller, there's our view, and there's our model. MVC, voila. Okay, it's that easy. Now, we need, in this model, to think a little bit about what its public API is. In other words, what does this model allow other people, like controllers, to do? Okay, that's one of the most fundamental things you want to do whenever you're doing design. Okay, is think about what the public API, everyone know what API means? Application Programming Interface. It's all the methods and properties. And so your public API is the methods and properties you're going to allow other classes or other data structures to access. So we really, really want to think about that. Quickly also notice that we've imported Foundation here, not UI Kit, because this is not going to be a UI class. Right? This is UI independent. This is the model. Now, I could say here, okay, let's create a class called Calculator Brain. Nope, not Brian, Brain. So I could do that, but I'm actually not going to do that. I'm going to use a different data structure here than a class. All right? I'm going to use a struct. Now, you're probably used to using struct in other languages, but you probably think of it as just like a little collection of other variables is a struct. In Swift, struct is a first-class citizen, very much like a class. Okay, and I'm going to talk about the difference between that in a second. And in fact, most of the commonly used classes in Swift are structs, like string, double, array, dictionary. These are all structs. They're not classes. So what's the difference between a struct and a class? I'm going to talk in detail about it next week, but I'm going to tell you two important differences, the two most important differences. One thing, classes have inheritance. Structs do not. Okay? So if you're building something that you think is going to need to be subclassed to be extensible, you probably want to make it a class. I'm going to make my calculator brain extensible in a different way, as you'll see, so it doesn't need to be a class. Okay? I could possibly change it back to a class if I change my idea later, but my current architecture, it does not need to be a subclass. So that's one difference. The other difference, huge difference, and the one that's going to take the most getting used to for you conceptually, is that classes live in the heap and you have pointers to them. Structs do not live in the heap, and they are passed around by copying them. Okay? We call the copying style value types. We call the in the heap style reference types, because we have a reference to them in the class case. We actually copy them around in the struct case. Now, you know, that might seem like a big restriction. I got to copy these things around. What if they're big? But as I mentioned on Monday, these things are passed around copy on write. So when you pass them around, if you don't actually change them, then no copy is actually made. Okay? But it's all behind the scenes for you. All right? So that's a huge difference. Now, why would I want my calculator brain to be a struct instead of a class? Well, I don't imagine I'm going to have a whole bunch of different people referencing it. The calculator brain is the brain for an MVC, so that MVC is going to access it, but I don't see a lot of other entities somehow trying to point to this thing, so I don't really need it to be reference type. Okay, I can have it be a value type from that standpoint. So it seems probably fine. Also, it's a great opportunity for me to show you what it looks like to make a struct, because making a struct looks almost just like making a class, but there's a couple minor differences, which you're going to see real soon here. Okay, so now back to the public API. What is the public API of this? Well, I know that this calculator brain is going to need a func that performs operation. Okay, for sure, because that's fundamentally what it does. It performs an operation. And we'll use the same mechanism we used on Monday to define it. I will have some mathematical symbol be the thing that defines what operation we're performing. Okay, and you notice that I made the external name be blank. It's a close call here as whether you would want it to be symbol. In other words, would I call perform operation like this? Okay, perform operation, symbol, whatever, or whether I want it to be blank and I say perform operation and I just put the symbol in here like pi or whatever. It's a close call here. This is a close judgment call as to which is better. I'm going to go with this because I think reading this code, perform operation pi, makes perfect sense to me. Adding the word symbol in there doesn't really make it any clearer to me. So that's the way I'm going to go with this one. Okay? What else do I need? Well, if you're performing operations, you have to have operands to perform on, right? If you're doing square root, you have to do square root of something, whatever. So I'm going to have some func that sets the operand as well. Okay? And again, I'm going to have no external name, and we'll call it the operand. And I'm going to have my entire calculator brain work in doubles. It's going to be a double precision calculator brain. So I'm going to have the operand be a calculator. Now, here's a case where I definitely know that I don't want to have an external name, because saying set operand 5.0, that's ridiculous. That's completely redundant. Don't need it. It's very clear if I do this, set operand 5.0. That's clear what I'm talking about. So no question in my mind that that's better. And then you set the operand, you perform operations. Guess what? You got to get the result. Now, I could have a func to get result or something like that returns a double. Right? That's one thing I do. But that's really not very Swift. Really in Swift what you would do is you'd say, here's a result var that returns the result. Now the only problem with that UI, or that API rather, is I don't want anyone to set my result. I'm the calculator brain. I calculate the result. So this needs to be read-only. Anyone remember how we can make a var read-only? No. Huh? Someone suggests let, and that's kind of not exactly what let does. Let makes it a constant, meaning that it's read-only, but it can only be set once, whereas our result is constantly changing. So we can't do let, unfortunately, but that's a really good guess. Actually, we do it with that computed property thing. Okay? Remember where we computed that display value and we had get and set? Well, we just don't do the set, right? This case, we're just not going to do. Just not put that on there. Boom. This is a read-only property. You got that? It's like current title on button. It's get only. All right, now I'm going to think a little bit about the internal implementation of this before I go and start using this thing. I know that a calculator brain internally, it kind of accumulates its answer as it's going. And so I'm actually going to have an internal var, and watch this, private var. I'm going to call it accumulator. I'm going to make it a double. Okay? So this is going to be internal. So now other people can't access this. That's what private means. And for all your homework for this entire quarter, I want you to put private in front of things that you think are internal implementation to any class you create in this course, okay? So get used to doing that. It's very important. These three are not private. They're public. I'm going to allow other people to call these, but this one is internal. Now, one thing you notice is I don't have any error up here that says no initializer. Remember that when I created a var in the view controller and it said that there's no initializers and I had to make user in the middle of typing equal false? Why don't I have to do it here? That's because this is a struct. And structs automatically get an initializer that will initialize all of their uninitialized vars. Okay? You get a free initializer. You don't get that with class. Only with the struct. So there's one difference between class and struct. So we're going to have a struct for calculator brain, or an initializer for calculator brain, that will take a double and it'll initialize this accumulator. But actually I don't want to do that. Because let me think of what is accumulator's initial value really want to be. When someone creates a calculator brain, I don't want to have them to tell me what the accumulator's initial value is, because I know what the initial accumulator internally, its initial value is when I start up. It's not set. So I'm going to make this be an optional. Do you see why I'm making that an optional? Because the accumulator, when I create my brain, I haven't accumulated any result. So I'm in this not set state. So that's a perfect opportunity to make this a double, or an optional, so that I can express that in my code. All right? So if I have this internal accumulator right here, how can I use that to implement these? Well, two of them are easy. Okay, set operand just sets the accumulator equal to that operand. Okay, because when you set a new operand to operate on, that replaces anything you have in your accumulator. It's what you're now accumulating. So that couldn't be any easier than that. And then get result, you're just going to return the accumulator. Okay? Now, we've got a couple of errors here that we have to deal with. What's this one right here? This looks perfectly fine. How could this be bad? Accumulator is an optional double. I'm setting it to a double. This has got to work. What's the problem? It says, I cannot assign to this property because self is immutable. Self meaning the calculator brain is immutable. And it's saying, do you want to fix this by making this method be mutating? You see it's trying to add this here. Another difference between structs and classes, if you have a method, okay, or a property that you're setting, that, well, if you have a method and it changes the value of this thing, you have to mark it mutating. You have to tell Swift, this method can change the value of this struct. Why is that? It's because of that copy on write thing. Remember I told you that structs are passed around by copying them, and when you write to them, then it copies it. So it has to know you're writing it by calling set operand. So you have to make set operand be mutating func. So that's the difference between class and a struct. Got that? What's this error down here? A different error. Anyone know what this error is? Louder? No? Okay, the problem here is we're trying to return a double. An accumulator is an optional. Okay, so it's saying here, hey, unwrap this. Now, I do not want to do this here. Okay, because it's perfectly valid for the accumulator to be not set. In fact, it starts out not set. And in fact, I can think already of another case where the accumulator is going to be not set. What if I say 5 times 3 equals in my calculator? After I say 5 times, my accumulator is not set right now because I need the 3 equals until I can get the result. So my accumulator is often going to be going back to not set. When we're in that weird 5 times 3 equals 5 times, accumulator is not set right now. 3, okay, the accumulator set again, equals, okay, here's the result. Okay, so I can't have this be exclamation point, or this thing's going to crash every time someone asks for the result after they say 5 times. So we can't have that. So instead, I'm going to turn result into an optional. And that makes sense too, because if someone using this object in the middle of 5 times says, what's the result? It'll say it's not set, because I'm in the middle of 5 times, right? And in your homework, you're even going to make it clearer to users of this why this might not be set. Okay? So you'll see that. All right, so that's a good start to the implementation of this thing. But before we go any deeper in this implementation, let's go back to our controller and use this public API that I just designed. Okay, I want to use it. So I'm going to go back to my controller. Now I want to have my controller and my model on screen at the same time, just so I can see them side by side. And the best way to do that is to bring up this assistant editor thing again, right? And you can go up to the top and you can actually manually pick, or I'm going to teach you one little Alt thing. If you hold down Alt and click on some other file over here, you'll get that to appear on the right. So Alt clicking means bring it up on the right. Okay, so here I have my model on the left, and here I have my controller on the right. So what I need to do now is fix this broken code that is doing model stuff inside the controller by using the public API of my model. Now, notice that touch digit does nothing when it comes to calculating. All it does is get the digits from the keyboard and put them in the display. It's not doing any calculating, so we don't have to touch that. Same thing here with this display value computed var. All it's doing is converting the display from a double to a string and back. That's all it does. It has nothing to do with being a calculator. That's just the UI for this particular calculator. So the only thing we actually have to change is this method, perform operation. Okay? Now, we know that this part in here is not belong in here. And in fact, I'll throw it over here in my model, even though it's not going to work there, but we'll throw it over there for now just to get it out of the way. Okay? So now we need to somehow use this API over here in this implementation. So let's look at all 3 parts of what we have to do when we perform operation. First of all, if we're in the middle of typing a number, we need to set that number as an operand. Okay? Because obviously, if the user is typing in a number and they perform an operation, that number they were typing needs to be an operand. So right off the bat here, I'm going to say if the user is in the middle of typing, then I'm going to set the operand. Now, how do I communicate to my brain here? Where is my brain? I don't have a var for my brain. So let's create a var, and it will be private, because the model is almost always private to the controller, because you don't want someone else reaching in and messing with this controller's model. So I'm going to make it a private var. I'm going to call it brain. Its type is calculator brain. Okay, that's good. Now, as soon as I put this line of code in, look what I get. The old, you don't have any initializers. That's because this is not initialized. So I'm going to initialize it by creating a calculator brain. And you create a calculator brain in exactly the same way that you create a class with the name of the type and then the parentheses. Now, we have no arguments in here because we have no uninitialized var. Since we made this be an optional, it's initialized to nil automatically for us for free, remember? So we have no uninitialized var, so we just do open parentheses, close parentheses. And of course, we don't need this type, right, because it gets inferred. So if we ask Swift what type is this, it says, oh, that's a calculator brain. Has to be because that's what you set it to. All right? So now that we have a model, our controller, this is the green arrow talking from our controller to the model, we can say, brain, set your operand to be whatever the display value is. Okay? And of course now we are not in the middle of typing, so I'll put that in here. Okay? So that's all we need to do to set the brain's operand. We only need to do it if the user is in the middle of typing something new and they hit an operation button. We need to give them that operand. Okay? Now, what about the stuff that was in here? Okay, we get this mathematical symbol of the operation to do. Now I'm just going to let the brain do it. So I'm just going to say brain perform operation, the mathematical symbol. That's it. I'm just handing that off to the model because this is not my job as a controller to do calculation. Okay, I'm a UI guy. Now, of course, after the operation is done, I need to set my display value equal to the brain's result. Okay, but of course I can't do this because display value is a double and the result might be not set because it's an optional. So I'm going to say here, if I can let the result equal the brain's result, in other words, if the brain's result is determined, then I will let the display value equal the result. That's it. Okay, so that little piece of code that we put has completely taken all calculation out of the controller and put it into this other camp, the model. And now we can spend the rest of this lecture making this really powerful model, and nothing is going to change over here. I'm literally never going to edit this code ever again. Okay? In fact, I'm just going to get it off the screen, and we're going to spend all of our time over here in the model. Okay? So let's start by making kind of really dirt simple implementation of perform operation here, which is try to get this code that was already there to work. And mostly that's just a matter of changing the names because this argument is symbol, not mathematical symbol, so we'll do that. And instead of setting a display value, because we're not in a UI anymore, now we're just setting the accumulator to that double pi, right? And same thing here, we're setting the accumulator to be the square root of the accumulator. Okay? Now this is a problem right here, this line. Why? Accumulator is an optional. You can't take the square root of an optional. So I could say, for example, if let operand equal the accumulator, so if my accumulator is set, then I can have the accumulator be the square root of the operand. Okay? Now, we have another warning right here on both of these lines. Why do you think there's anyone know why this is? We've seen it before, 5 minutes ago. This modifies this calculator brain. So this method, perform operation, also needs mutating in front of it. Okay? So I'll fix that, add mutating. Okay, adding this mutating takes a little bit of getting used to, but it's great because this compiler notices it and it's going to always be reminding you to do that. Okay? So believe it or not, we now have an MVC version of this calculator, and if we run, it should just work. All right, here we go. Let's see. 7, 8, that's still working. Okay, that was in the controller. Pi, whoa, that's working. It's going off to the model, and this is actually executing, and it's causing the accumulator to get set to that double pi, and then it's looking at the result and putting it in display. How about 81 square root? Square root? All right, excellent. Okay, so now we're starting in a place where we were exactly where we were before, but we split off all of our calculating code into this little class right here. So this is a great opportunity now to enhance this to the max. So we are going to use all kinds of cool Swift stuff that you probably do not see in other languages to make this a much more extensible calculator. Because right now, man, if I want to add more operations, I just get this huge switch statement, case this, case that, because then I'm going to have to do if let operand equals accumulator every single time for the things that are unary operations like square root. Imagine when I have the binary case like 5 times 3 equals, I'm going to have to do the figuring out how to deal with the times and the equals for every single case. Forget it, I can't do that. I need to build an engine here that can deal with constants, that can deal with these unary operations like square root, that can deal with binary operations like multiply and plus and things like that. Okay, so that's exactly what we're going to do. We're going to enhance this model. Now, as we do all this enhancement, we're not going to change it externally at all, and so the controller will not change. That's what's really cool about this. We can do our model development independent of our UI, once we have a UI that kind of does the basics. All right, so what are we going to do here? Let's focus first. Let's get rid of this code, because we know that's a mess. We're not going to do that. Let's focus on constants. Wouldn't it be kind of cool if I could like build a table? Okay, I'll do square brackets to hold my table. And in this table, I had like pi and double dot pi, and then maybe I had e's. Everyone know what the constant e is? Mathematic 2.71 something. We have a nice symbol for that. Not quite as nice as double dot pi, but it's called m under bar e. So, and I put all my what if I put all my constants in a table, and then here in perform operation, I'll just look up the symbol in that table and get the value. Wouldn't that be a lot more extensible for constants, right? I could add all the constants I want. I just one line of code each. Okay, that would be a lot better than putting extra case this, blah, blah, blah. Okay, so how can we do that? We need to create a table. So how do we create a table in Swift? We use the struct called dictionary. Okay, so dictionary is how you create a hash table of things. And so I'm going to create a private var. I'm going to call it, I could call it constants, but I'm going to call it operations because I'm eventually going to enhance it to work for all of our operations. And it's going to be of type dictionary. Now dictionary, you're going to see a new feature in Swift right here. You have this feature in Java as well. It is a generic type. So a dictionary, it can be a dictionary that goes from almost any kind of key to almost any kind of value. Okay, the key has to implement a certain protocol. It basically has to be hashable. Okay, so as long as it's hashable, then it can be a key, and then the value can be any type. So you specify that, same as in Java, the key type. So I'm going to have my key be a string, like pi or e, and then the value is going to be a double, like double.pi here, or m_e. Okay, and believe it or not, I can actually say equals this syntax, and it will create one for me with that stuff in there. Okay, so open square bracket, key colon value, comma key colon value. That's how you can put a dictionary. Now, of course, you can add things to a dictionary and remove things and get things out of a dictionary. I'll show you that in a second. But this is a nice way to do this. So let's do that. Okay, so we have this nice dictionary. So now we could use this dictionary of operations and perform operation. I'm going to say if I can let the constant that I want equal the operation that matches that symbol, then, now why am I doing if let here for operation sub symbol? This operation sub symbol, that's how you look up a symbol in a dictionary, right? Operations is a dictionary. Click on it, right? It's a dictionary of strings and doubles. So you look it up. When you look it up, it returns an optional of the value. Why? Anyone think why it would do that? Exactly, it might not be in the table. Okay, what if I say operation sub x? That's going to return not set because there's no x in this table, only pi and e are in there. Okay, so that's why I have to do if let there. And if the constant is there, now I can set my accumulator equal to that constant. Okay, because this constant is going to be a double because this is a dictionary that has doubles as its values. Okay, that's cool. Let's go ahead. Let's run it. That's all we need to do. So now we built, for constants only, a much more extensible internal architecture here to our calculator brain. So, of course, square root's not going to work, okay? But pi works. And if I had an E button, it would do E. Okay, everybody cool with what I did there? But of course, that's kind of useless just for constants. We want to be something like this. Watch this. Quote, do my emoji and symbols here. There's our square root. Square root, colon. What do we want to put over here? How about square root? Okay, and maybe like cosine. Put cosine there. Okay, wouldn't that be cool if we could do that? Okay, because now we'd really have an extensible table. It can do constants and also could do these unary functions. But we got a problem here because square root is most definitely not a double. Right? Square root is like a function, so that's no good. So we're going to, if we want to have a dictionary that has mixed things in it, we need to create a type here that represents those mixed things. So that's what we're going to do. We're going to create a new type. Okay, this is going to have a data type that you're going to be somewhat used to other languages, but you're going to see it's much more powerful in Swift. I'm going to make it a private type that's embedded inside my calculator brain. So you can have types within types, and that's just a scoping issue. That's just a naming issue. Okay, the name of this is going to be calculator brain, the dot, what I call it here. And it's not going to be a struct or a class. It's going to be an enum. Okay, does everyone know what an enum is in other classes? It's basically a data structure that has discrete values. Right? It can only be one, like case this, case that, whatever. It can only be one of a discrete value. And the same thing here in Swift. I'm going to call it operation, and it's going to have case constant and case unary operation. So those are the two kinds of things. And then I'm going to make this dictionary return an operation instead of a double. Okay? So that means I have to change all of these to say operation.constant, because this is a constant. We'll just comment that out for a second. And then this is also an operation.constant. This one would be an operation.unary operation. Might even just call that operation.unary. We'll say unary operation. Operation.unary operation. Okay, cool. Okay, we can't do this anymore, of course, because now it's not a constant that we're pulling out of there. It's actually an operation. Okay, and obviously we can't do that because this constant here is now an operation, not a double, so we can't say that that equals that. Okay, so this is good. It's getting better. Got our table to be able to have both things, but in doing this, I've lost the fundamental meaning of all of these things. I commented it out. So now this table is kind of useless, right? It knows that pi is a constant. It knows the square root is a unary operation, but so what? Because we can't do any of them. And this is where something you've heard of before, associated values, comes in. Remember, optional has this thing where when it's in the set state, it has this associated value that's associated with the set state, but it's not associated with the not set state. Okay, optional is an enum. It's an enum with two cases. The not set case, which is called none, and the set case, which is called sum. And in the sum case, it has a little associated value with it. And we can do the exact same thing. Okay? In our enum, when the case is a constant, we can have an associated double. And that's, we just put it right there, and we could have multiple associated values. We only need one for constants, but we can have this associated value. Okay, so associated values are something not specific to optionals. It's for all enums in Swift. So this is super powerful because now when I add a constant into this table, for example, I can just associate double.pi with it. Same thing with this constant. I'll just associate the value of e with it. Okay, now we'll get to these ones in a second. A little more complicated there. All right, so now I've got a table got constants in there, and I actually know the values. So down here, when I get the operation out of here, right, this is of type operation. It's one of these enums. How do I look at each of these and get this associated value? Well, how would you look at the values of an enum in another language? You would probably switch on them. So I'm going to switch on this operation, and I'm going to do a case for when it's a constant, and I'm going to do a case, we'll do colon and break, and I'm going to do a case for when it's a unary operation. We'll break on that case. Okay? And I don't even have to say default here because these are the only two values that an operation can be because it's an enum. It only has one of these two values. Now here you can see it already put this in parentheses right here. Okay? It wants to help you get that associated value out. Okay? Awesome. How do we do that? We say let associated constant value, or whatever we want to call this variable. And that means that inside here, associated constant value is going to be that associated value. Now, we would never call it associated constant value. We'll rename it in a second. But now what are we going to do with it? Well, in the constant case, we're just going to set our accumulator to that associated value. Now, why wouldn't we call this associated constant value? Well, first of all, anyone reading this code knows that this is the associated value, so you don't need to say associated. And we know it's a constant because we're in the constant case, so it's really a waste to say that. So we would just say value here, because that's what it is. It's the constant value that's associated with it. Okay? We don't need break. Everybody got that? By the way, switches are slightly different in Swift in that they don't fall into each other. Okay? When you have constant, it does this and it's done. It doesn't go down, fall down to the next case. Okay? So you don't need break at the end of every single one, which is really nice. All right, so this is great. So should this work? I think so. Let's try it. All right, so pi, again, square root we haven't done anything with, but pi should work. Let's try. Bingo. Okay, so you see how pi is working here? We're saying to look up pi in this table, it finds that it's a constant operation with this as the associated value. We switch on that operation, find that it's a constant. We let value equal the associated value, and then we just set that to the accumulator. And now that's our result. The next time they ask for a result, that's what we got. Okay, now let's do unary operation. Okay, this one's a little tougher, okay, because really what I want to do is this. right? The associated value wants to be those functions. Can I do that in Swift? Of course. It wouldn't be here if we couldn't do that. How do we make an associated value be a function? Well, the cool thing about Swift is that functions are normal types. Just like a double, any struct, a class, no difference between that and a double. So how do I go back up to my enum and have an associated type here be a double? How do I say the type which is a function that takes a double and returns a double? Because that's what I want in here. This is a unary operation, so I need this to be a function that takes a double and returns a double. Well, you just type it, function that takes a double, returns a double. Just type it right in there. Okay? This is a type, just type just like string, but it happens to be a function. Okay? Now, I'm going to take a time out right here and just to show you a little more about this function types to make sure you're getting this. And what I'm going to do is I'm going to create a new thing called a playground. So a playground is just a place we can play around with iOS code. Okay, so you just say new playground. This is going to be an iOS playground. I'm going to call it my calculator playground. You can call it anything I want. It's going to save it on disk so that when I type in here when I'm playing, it gets saved for the next time. You can put it anywhere you want. I recommend it same place, home directory developer. Okay, don't put it inside another project or whatever. And you can see the playground looks like this. On the left, you can type any iOS code you want. And on the right, it's going to evaluate what's on the left and show you not only, well, it's basically going to show you the result or the value of any var that it finds. So here it found this var string, str, and it's showing you the value of str over here. Okay? So I could say, for example, let I equal 27, and it's going to say that 27 is what it sees there. But I'm going to create a new var. I'm going to call it f. Its type is going to be a function that takes a double and returns a double. Okay? That's its type. I could have said f var f string, but I said it's a function that takes a double and returns a double. And I'm going to set the value of f. I'm going to set it equal to square root. Okay? I mean, it's a function that takes a double and returns a double, so I can say f equals square root. Now, how do I actually call this function? Well, I'm going to let x equal f of 81, for example. Okay? So I call this variable right here, which is a double that takes a double, just like it was a function. And if I were to go back and change this to cosine, look what happens. Okay, so now f is cosine, so now I'm getting the cosine of 81. I could even write my own function. How about func change sign? Let's say it takes a double and returns a double. Okay, it's just a regular function, returns the change signed operand, right? Operand changed sign. So now I could go down here and change this to be change sign, function I wrote. And now I'm getting minus 81. Okay, so everyone's seeing how this type functions as a type, they're just normal type. Absolutely, you can use a function as a type anywhere you can use any other type. Argument to a method, associated value in an enum, local variable, anything. There's no restriction on it. Okay? I'm even going to take the, oh, notice also, by the way, that change sign has an external name, operand. When you call change sign, it looks like this. See, you got this operand. It's okay. When I call it down here, I don't have to say f operand. In fact, I can't say that. And that's because f is just a function that takes a double, returns a double. It can be any function that takes a double, return a double. So you can't have those external names in there because it can be any function. As you change it, you can't be changing this. So anyway, just a minor note there. So I'm going to take change sign, actually, and copy and paste it back into my code up here. So I just made a new function. It's even a nice global to this file. Function called change sign. And I could go back here and say, change sign, let's do something for change sign. I think I can remember how to do this. Yeah, controls, command, control, space, something like that. Let's go here, edit. Okay, we need something for change sign. I think I have one here, this one, okay? It's not really change sign, but that's all right, we'll use it for that. And so this is an operation, no, not a KFCF property, an operation, .unary operation, change sign. Okay? Perfectly legal. Okay, everybody got that? So now, down here in our switch, in the same way that we grab the constant value with let value, let's grab that associated function with let function. And again, we can call this, doesn't have to be function, this could be f, it could be func, can't be func, because that's a keyword, but function it could be. Okay, so we got this unary operation. What are we going to do? Well, we just want to call this thing with the accumulator. Okay, but of course we better, and sorry, we want our accumulator to equal calling that function with the accumulator. We better check though to make sure this is not nil. So I'm actually going to do something a little different. Instead of if let, I'm going to say if the accumulator does not equal nil, then we'll do this. So this is another way to protect against this crashing your app. Okay? Somewhat similar to if let operand equal accumulator, but I'm just actually checking to see if accumulator is in the not set state. Accumulator isn't optional, so it can be equal to nil or it's equal to something else and has an associated value, like these things. All right, that's all we need to do. Let's take a look. Oops, we have errors there? No, we don't. Okay. All right, so pi, still good. 81, square root, working like a charm. Okay? And again, if we had cosine in those, which we are going to add those in a second, but for time I'm not adding them in, but we'll add cosine and all. Actually, forget it. Let's do it. Let's go back to our UI right here, and let's add those other buttons. Let's put cosine in here, cosine, and let's even put our little change sign that we did there. Control, Command, Space. Yeah, there we go. Change sign. Put change sign in there. So we'll put those in there, and that's all I need to do in my UI. It can just run again because my brain, my model, already knows how to do those operations. So I can put any operation my brain knows how to do into my calculator's UI, and it'll just work. So here we got, how about pi cosine? -1. All right. Change sign? +1. All right. So this is really looking nice because our calculator brain, still hardly any code in here, and yet now it's fully extensible for both constants and unary operations. What's next? Binary operations. 5 times 3 equals. Okay, much more difficult, right? Because there's actually 2 operations there when you do 5 times 3 equals. There's the times, which puts you in this weird pending state, and then there's the equals, which actually finishes the 5 times 3 equals, right? So I'm going to need some data structure to remember the 5 times until the equals comes along. Okay, so let's do that. Let's add a data structure for that. Actually, before we even do that, let's back up here and talk about all this mess. What's this going to be like for binary operations? So we need a binary operation here. And what's its type going to be? What's its associated value want to be? What do you think? How about a function that takes 2 doubles and returns a double? Right? And we're also going to need an equals operation as well. And so we can just go down here and do, for example, times. Let's do times. Oops. Space. There we go. I've got a nice mathematical times symbol here. Okay, we have to do an operation, dot binary operation. And we need multiply basically here. So I'm going to make my own multiply function. So we'll just put multiply there. Also, of course, I need equals, which is operation.equals. Okay, put those in my table. So this multiply, where's that? There's no function called multiply. Well, just like I did change sign up here, I'm going to create my own little func, multiply. It's going to take op1, which is a double, and op2, which is a double. It's going to return a double, of course. Oops. And it's just going to return op1 times op2. Okay, so I got this nice function up here. Fits in here nice, no error. Everything's fine there. We got that. So now we have the hard part of what do we do with the case here that is binary operation. We still have a function, but now it's a function that takes 2 doubles and returns a double. All right, so what are we going to do here? Again, like I said, we're going to need some kind of data structure to remember 5 times and wait till we get another case, which is equals. Okay, and we're going to have to do something in here. So let's take a time out here and create another data structure to remember 5 times while we're waiting for 3 equals to happen. So I'm going to make it a struct. It's also going to be an embedded private struct, just like this was embedded private enum. So the name of this enum, its full name is calculatorbrain.operation. But as long as I'm using it inside this struct, we can just call it operation, like we did right here. Okay? So same thing here. I'm going to call this one pending binary operation. Okay? It's going to be a pending binary operation. And it's going to have two vars. One is the function, which is going to be, it takes two doubles, returns a double. And it's going to have the first operand, which is a double. So it's just going to be a struct that holds those two things. Now, never forget that structs in Swift can have methods and things like that. In fact, I'm going to put a method on here just to remind us of that. I'm going to have a func called perform, which will perform this binary operation. Now, what does it need to perform it? It needs a second operand. Okay? And it's going to return a double. Okay, now, notice the naming here. Why did I use this naming? With as my external and second operand as my internal. Well, second operand is the internal because that's what this argument is. And in my code here, I want the first operand and second operand to have the right names. But I'm using with because when someone calls this, they're going to say perform with 5.0. And of course, they're performing a pending binary operation. So this makes perfect sense. If you say binary operation, perform with 5.0, it makes sense, right? And these internal names, even though they're only used internally, you can think of them as part of the documentation. Because anyone who sees the documentation of this method is going to see both with and second operand. See, so they're kind of getting a little bit of documentation that with is with the second operand to this binary operation. Okay? And how would we perform this? Well, we would just return the first operand times the second operand. Okay? But we're not doing times here. We're doing this function. So I'm going to call that function with the first operand and the second operand. Okay? It's a really simple little method, but I just want to make it clear. Notice this method doesn't have mutating on it because it doesn't actually change the pending binary operation, right? It just returns the evaluation of the function, but it doesn't change any internal values. Also notice these are lets. That's because I'm going to create this pending binary operation in a moment with these two things set, and I'm never going to change them. So they are constants in this struct. Now, also notice no error that says you don't have an initializer and you have these two uninitialized vars. Again, this is a struct. Structs automatically get a free initializer, which will initialize all of these things. And in fact, let's use that right now. I'm going to create a private var, which I'm going to call PBO, pending binary operation, but only temporarily because this is a bad name. I'm mostly doing it so things won't wrap because I'm using a big font so you can see here. I'm going to go actually change this back to a better name in a second. But this PBO is a pending binary operation and optional. Why is this an optional pending binary operation? Because we're not always in the middle of a binary operation, only when the person says 5 times. Okay? If we said 5 square root, we're not in the middle of a pending binary operation, so this has to be not set. Are you starting to get a feel for how we use optionals all over the place to be semantically exactly what we mean? And here, if we're not in the middle of a pending binary operation, this is not set, so it's an optional. All right, so when you press the times 5 times, all I'm going to do here is remember or create a pending binary operation. So I'm going to say PBO equals pending binary operation. Now when I tab here and I do the open parentheses, look, it starts showing me that there's already an initializer. One that tab takes function and first operand. Woohoo! So this is that free initializer I get because I'm a struct down here, not a class. So what is the function? Well, that's just this function right here that we got as our associated value. That's the function in the binary operation. And what's the first operand? Well, it's our current accumulator, right? 5 times 3 equal, it's the 5. Okay? Now, here I'm unwrapping it, so I better do if accumulator does not equal nil, because I don't want to crash here. And so that means I'm going to ignore times. If you press times and you haven't given me an operand, I'm just going to ignore that. Like if you start up your calculator and say times 3 equals, I'm going to ignore it because I don't have any operand to times it by. Okay, so that's good. That's what I want. Also, when I have this times, I'm going to set my accumulator here to nil because I'm in this weird half state 5 times. My accumulator is waiting for the 3 equals to be set to anything, so I'm setting it to nil, not set for the moment. All right? So that's it. That's all I need to do when times is hit. But now when equals is hit, I have the 3, and I need to calculate 5 times 3. So I need to actually call this perform down here. So I'm going to put this in its own little method. I'm going to call it perform binary operation. Or actually, we'll even say perform pending binary. Binary operation. Okay, I'm putting it in another method. You'll see why in a moment. Okay, so I'm going to do a private func, which is that. And what am I going to do in here? Well, here I'm going to perform that pending binary operation. So I'm going to do pbo.perform. And what am I going to perform with? I'm going to perform with the current accumulator. Okay? Now notice this put a question mark right there. Okay? The reason I need a question mark there, really what I wanted was exclamation point, because PBO here is an optional and I need to unwrap it. But what's really cool is if instead of exclamation point you put question mark, then it will unwrap it, but if it's not set, it will just ignore this line. Ignore the rest of the line. Okay? So that's kind of a cool feature. But I'm not going to do that because I didn't really talk enough about it. So I'm going to unwrap it. So here I need to make sure PBO is not nil, and I need to make sure that the accumulator is also not nil. Okay? Because if those two things aren't true, I don't really want to be doing this line of code right here. Right? And so I'm performing it. I get the results, and I'm going to put that in my accumulator. Okay? So my accumulator is no longer nil. Why is this happening? The 3rd time. Mutating. All right. Excellent. I love it when people catch on quick. So yeah, that needs to be mutating because this is changing the accumulator, so it's modifying the internal state of the calculator brain. Now the other thing is, no longer am I in the middle of a pending binary operation, so I have to set that to nil. Okay? Because I want to be consistent in all my code that when that's nil, I'm not in the middle of a pending binary operation. I just had the 3 equals. Okay? Makes sense? Now, I told you I didn't like PBO as a name. It's a bad name, okay? Someone looking at it would have to go look at the declaration to figure out it. A better name here would be pending binary operation. So I'm going to change it to that. And here's how you can change the name of something all throughout the context that it's in. You just mouse over it. I haven't clicked on it. I moused over it. You see that little arrow that appears? If you click on that, you get a menu, and you can say Edit All in Scope. And now, when you change this, it's changing it everywhere. Okay, so I changed it from PBO to pending binary operation. You can see why I did that, because I didn't want the wrapping to happen when we were first doing it. Okay? So that's it. That's all we need to do for our little pending binary operation. So let's go ahead and add some binary operations to our UI. In fact, I'm going to add a few that we don't even have in our table yet. So let's do times. Space? Yeah. So here's times, but I'm also going to do the other ones here, divide and plus, and just so we don't have to come back here again to do that. So there's divide, and okay, we'll do another one, do plus and minus here. So I'm doing command control space, I guess, to get this little emojis and symbols thing. And a plus. Okay, and we need one other thing, equals. Got to have an equals button, so we'll put that down there. Okay, so now we only have times, so times is the only one that should work, but let's see. Actually, I'm going to bring back that code so you can see it at the same time. It's hard to see it all at once, but. All right, here we go. Okay, 4 square root, that's still working. Pi, still working. How about 8 times 6 equals? Woohoo! Square root? Nice. Okay, so times is working there beautifully. Now, the only thing is we have to do divide and all that. So I guess what I have to do is I go create this 4 times, and I'm going to have to go here again and control space again. We'll do divide. And we'll go here and control command space, and we'll do plus, and then we're going to go here and we'll do command space and we'll do minus. Okay? Now, am I going to have to write a method divide and go up here and copy and paste this and do one with divide? You know, if I have to do that, all of a sudden I'm feeling like this whole table business really didn't buy me that much, right? Because I'm still having to create a method for every single binary operation I want to do. I mean, for unary operations, it was nice because I had all these built-in ones. I did have to make this one method, but I could even see with unary operations, I want to create a bunch more, and I'm having to create these other functions. It's not really working out for me, okay? So how are we going to fix this? Well, we're going to use a feature in Swift, which is really powerful, and you're going to have to get used to it because it's not in a lot of other languages. It is in some other languages. I don't want to make it sound like it's not around. It's definitely around, but may not be something you've used in any languages you've used. And it's called closures. Okay, how many people know what a closure is? I've heard that before. See, almost none of you. So a closure is a function embedded right in line of your code. Okay, and so we can actually take multiply right here, select its code. I'm going to cut it, go down here to where I used it, and paste it in there. Now, it doesn't quite work. There's two things we need to do. One, this open curly brace needs to be at the beginning. So we're going to replace this open curly brace with the keyword in and put the curly brace at the beginning. So that's how you take a function and put it right in line. You just literally copy and paste it right in there, change the curly brace to in, and move it to the beginning. Okay? Got that? So now we don't even need multiply. All gone. Now, this doesn't look much better. Okay? It's still a lot of typing stuff in. But let's use Swift's inference of type to make this a lot nicer. Swift knows that this right here is this, the associated value of that type. So it knows that this down here is a function that takes two doubles and returns a double. So we don't need these types right here. Get rid of those. Okay, now it's starting to look better. In fact, maybe if I go here and put some things on the same line, now I'm almost like, okay, yeah, no, now I'm liking it. Okay, but we can do even better than this. Swift also knows that this returns something, so we don't return. Okay? Swift also will let you have any number of arguments you want called $0, $1, $2, $3 for however many. So I don't need that or that. I can say $0 times $1. Okay? Now I'm winning. Okay? Now the essentials of what is going on here is right there, and there's no extraneous types and all that business. And of course that means for these other cases like divide, I can say divide, and for add here I can say plus, and for subtract I can do minus. Even for our friend change sign right here, okay? We can take this, copy it, paste, get rid of all this junk because this is just minus $0. Okay? So this closures allow you to do this thing where you get the essentials of what you're doing right in there in line. So you're not having to go look at some other method somewhere like change sign up here. The other thing closures allow you to do is to pass off to methods some piece of code to execute if something fails, or when something completes, or do this and animate it while you're doing it. For example, you're going to see API like that. So being able to pass these methods around, you're going to see, is really makes for great, great API. So you're just seeing the simplest possible use of it here. We're just using it as the associated value, but imagine it as function parameters and things like that. It's pretty incredible. Okay, so let's go see if that works. All right, 4 times 5 equals 20, square root, cosine, change sign, pi, cosine. This all working beautifully. And now we can add as many new operations as we want with one line each. One line each. Okay, so you see how I've built a struct here that's extensible without having to do subclassing and all that stuff. I can just add things. And I could even go further and make this public. If I made this operations table public, I'd also have to make operation public, then other people could get my calculator brain and add operations to it. Okay? So very, very extensible, not requiring any subclassing whatsoever. So structs can often be just as good, if not a little bit better, design point for classes. All right, the last thing that I want to do here, let's go back to our simulator, is talk about the layout of the UI. You see I have this layout right here. Let's look what happens if I rotate this into landscape mode. So I'm going to go up here in the simulator and go to Hardware, Rotate Left. Okay, my calculator is now completely unusable, okay, because there's no equals. So I can't even do 5 times 3 equals, right? So this is completely useless. I guess I can still do pi, but clearly this is not what you want, right? When you rotate, you want to use that space in that way, okay? And I promised you we were going to build a UI that would work in all those things. And in fact, we're going to do that right now. Let's go back to our UI. And doing this is not going to require any change to our controller or our model. Okay, this is purely something we're going to do in the view. And we're going to do it with this business up down here. Okay, this multiple phones. We'll be able to click here and see how things look in all these different orientations right here. And our basic strategy is that we're going to stack all these buttons into rows, and then we're going to stack all those rows on top of each other, and then we're going to stack that with the display to make this kind of block that has our UI. Then we're going to tie the edges of that block to the edges of the device, so that as the device changes, that block of stuff gets stretched out, or whatever, and the stuff inside is going to automatically know how to resize the buttons and stuff to lay out. Okay, so that's all we need to do to make that happen. Now, to have nice rows and columns here, I'm going to add one more button, which you need for your homework anyway, which is a dot button. One of your homework assignment items is to make floating point input possible, right? This is already a floating point calculator. I can say 4, 45, well, I can't type here, sorry, but I can type 45 and hit square root, and it would give me a floating point number, right? But you can't enter any floating point numbers because there's no dot, right? So that's part of your assignment. So I'll put that in there for you. Okay, so now I'm going to take this row and I'm going to put it into a stack. It's going to be a horizontal stack on its side. And you do that up here with Editor, Embed In, Stack View. Okay, so when I do that, see, it stacks them up horizontally. And I can inspect that stack. It's selected right here, and you can see Stack View right there. It's horizontal. I'm going to put some spacing in there. 10 points of spacing. I'm also going to make sure that they're equally spaced. So I want each of the squares in there to be the same width. All right? So same thing here. Let's go this one. Now there's actually another way besides going up here, Editor, Embed In. There's a button right here for it. It's so common. There's a button right there, Embed In Stack. So boom, I'll do that. Again, I'll put a space in here. Notice that the cosine button is wider than the 1, 2, 3. So I'm going to say fill equally and make them all the same width. Again. Oops. Sorry. Again, so we'll do 10 and fill equally. Same thing here. Stack. Fill equally. 10. And we'll stack this one. Oops. 10. Okay. Now I'm going to take these horizontal stacks, these 5 horizontal stacks, and stack them vertically. So I'm going to embed. Notice that it's pretty smart. It noticed they were above each other, so it automatically put it in a vertical stack. But it pushed them all over to the left in the stack, and I want them to spread out across the stack. So I'm going to have the alignment here, instead of leading, be fill. And that's going to fill the whole width. And of course, I want spacing here as well, so we'll do that. So look at this. I got this beautiful keypad right here for my calculator. Now I'm going to hook that up to this display. I'm just going to select them both and say stack them. Okay, it puts them in a stack. A left line aligned it again, leading aligned it there. So I'm going to say fill. I don't want fill equally here though, because if I do fill equally here, it's going to make this display the same height as the whole keypad. So I don't want that. So I just want fill. I want to fill the space. But I do want the spacing here, so we'll do 10 points again. So now I've got my whole UI in a nice little rectangle here. And I'm just going to tie the edges of this UI to the edges of the device, basically. Okay, now I'm going to start, I'm going to start here Yeah, be careful a little bit about that too. If you click on something and drag it, see, it might try to drag the inner one away. A trick for not doing that, there's two tricks. One is you can do Command Shift, I believe it is. Yeah, Command Shift will let you pick which one you want under the mouse. Okay, actually, it's Control Shift. Control Shift under the mouse lets you pick it. But another easy way is to use Drag Select to select the one you want and then pick it up. Okay? So I'm going to use the blue lines actually to put this at the proper space on the left edge and top. And now I'm going to do the magic to hook it to an edge. And I do that with the Control key, just like we did dragging into the code. But here I'm going to drag from this selected thing, make sure the whole thing is selected, and Control drag up to the top. So we can tie it to the top. And when you let go, it's going to say, what relationship do you want between this big box and the top? And really it's talking about the outer edge. And you could try and make them the same width or the same height, which doesn't really make sense here. Or you can pin this vertical spacing to the top layout guide. So I basically pinned it to the top. And same thing here, I can go to the left and pin the leading space. And I can go to the right and pin the trailing space. And I can go to the bottom and, the bottom, and pin the bottom space, the vertical spacing at the bottom. Now, we're just seeing pinning it to edges, but you can use this mechanism to control drag between any two elements and say, make these two the same width, line up the left edges, line up the tops. You see what I'm saying? And once you have that ability to have all your items have rules of their relation to each other, now you can imagine how you can rotate the whole thing and have it all look good because it's following rules about what to do. Now, one thing about these two pins, okay, those I pinned to where I wanted them, but these two pins are not what I want. It's pinning it this far from the edge. So how do I fix that? You can actually double click on that. If you double click on this I-beam, it says, yes, I'm pinning this 113 points from the edge. And you can go up here and try to pick standard value. But that's grayed out, so we're going to use 0. So you almost want either standard value, if available, or 0. So in this case, 0 means 0 points from this layout guide edge. Okay? And same thing with this one down here. I'm going to double click. By the way, we can also see these things. Okay, if we select this, we can go over to the size inspector. You can see all these things down at the bottom here. Okay? All these connections to the edges. All right, see this one's 301. So I'm going to double click on this I-beam. And here, standard value is available. So I'm going to pick the standard value. Okay? And it puts it there. Now, so it tied it to the bottom and stretched this out. Now, it didn't quite stretch out the way we wanted here, right? So some of these rows in the inside, we didn't get the right attributes on. So let's go back and check them all. We got fill equally horizontally in all of them. Yeah, we do, right? And how about this? Here, I'm going to use the control click. We'll pick this stack view. See this one, okay, this is this inner one. Wants to also be fill equally, right? We want all these rows, not including this top guy, but all these the interior rows to be the same. So I'm going to go fill equally here to fix that. Okay? So now I have this thing that can stretch out because it's got these stacks that have rules about how to fill, and then I've hooked them to the edges so that now when I switch orientations, it adjusts. Even if I go to a smaller device, okay? Or a large device. Now, one thing that's interesting about the very smallest device, an iPhone 4, is that in this orientation, it can't fit everything. You see that? The display, it can't fit it. So this is why it's great to be able to see this in Interface Builder, because we could go back here and pick a smaller font, for example. We can even have our font be variable, but there's no way to have the font automatically squinched down, unfortunately. There's no auto shrink for buttons like there is for labels. So sorry about that. But we would pick a smaller font that would work on all of our platforms maybe. Okay? All right, so we have this, and of course now if we run it in the simulator, we can rotate it in the simulator as well and see it working there. And if we had a device, we could run on our device and do it there. So here we go. Here's our iPhone 7. 7 times 9 equals. It's still working. Square root. That's good. And when we rotate, by the way, I'm going to rotate using Command key. Okay, Command left and right arrows. You'll see it down in the lower left corner here, but Command rotate. See that? Okay? So you can see we had to do very little to make this thing adapt. And this is a fairly simple UI, a lot of rectangles. More complicated UI, we'll do a little bit more. And in about week 4 or 5, I'll go into detail about how we build these, even for complicated UIs, how we build these rotatable things, etc. Okay, so that's it. Your homework is basically to reproduce what I did in these first 2 lectures, and then add a couple of things, add a little label up there, add some buttons, change some colors, that kind of business. Pretty straightforward. Make it work with floating point input, and that's due next Wednesday. I'm here if you have questions, and I'll see you then.
For more, please visit us at stanford.edu.